All right, well, thank you for joining us this morning. I'm Josh Redden, a U.S. Sales Manager for Haltech, and this is...
I'm Nick. I'm a technical consultant for Haltech.
Tech extraordinaire.
Yeah, something like that.
So yeah, we didn't really have a script for anything this morning, so I was going to kind of just let this be a discussion. If you all have questions, we're happy to answer them.
It's like we're trying to talk up here. We're just down there making noise.
But we also brought some ECUs to kind of show off, just let you all touch and feel and take a look at them. So I guess we can just go through the line and talk about what we brought and what we have at the moment.
Play Man of White real quick. You've all seen this guy before, the old Elite 2500. It's been around for, God, it's 2010, I think, is when it was designed. It came out in 2012.
11 years now.
So this ECU is super old, but we've kind of kept it relevant with firmware updates over the past 10 plus years. So even though it's been out for a long time and uses technically old hardware, it's still pretty relevant as far as like modern ECUs and stuff go. Like it still does a lot of stuff that a lot of our competitors don't do, with it being 10 plus years old.
And even coming into a new generation of ECUs, it's been product to spec.
That's gonna happen a lot.
Yeah, it's okay.
So even with the new line of ECUs coming out, we've brought these up to par with the new line with updates. So it's one of the things I guess separates us from a lot of the competitors is that you're not stuck.
Yeah, no one else takes an old product and makes it do new things. They just make you buy the new product. So like this ECU when it came out used ESP software, which was the Elite Series programmer. And when the Nexus came out, it got NSP, which was the Nexus Series programmer. Oh, the engineering team spent probably close to a year rewriting all the code for this ECU to make it use the new software. And when that happened, you actually got more data logging channels, a faster data logger, access to e-gates, access to keypads, all kinds of new features, functions, all this stuff, and it was free. Like you didn't have to pay anything, just click a button and it updates it, and then you could use the new software that we designed for our new ECU. And as of right now, no other company has done that. They come out with a new product, they come out with a new software, you want the new software, you want the new things, you gotta buy the new ECU, you can't just use what you have. So
is the old hardware at a disadvantage because the processing is a little bit less than
yeah,
the new
100%.
stuff?
Think of your cell phone from 2010.
Sure.
Think of a TV, a computer, anything. Like electronics change literally monthly.
Yeah.
So all of the stuff in here, when you think about this thing has the 2-core processor in it. All right. This guy has 4 processors. 2 of them are 8-core and 2 of them are 2-core. So when you just look at the processing power alone, like that's astronomical. And that's what allows this thing to do so much more. Like this, when these first came out, these would do 30 channels of data logging. Now they do up to 60 because of the NSP software. When we rewrote the code, they made it a little bit cleaner. You need to think the technology from back then, even as far as like writing code and how you process things, like all of that has become better. We've learned how to do things in a cleaner, more efficient way.
I will say too, with from a production standpoint, we build all of our own boards in-house. We don't farm that out to anybody. All of our ECUs are built in Australia in Haltech headquarters.
They're all designed by us too. We don't outsource any design.
Yep. So these boards, like you said, they've been out for 10 plus years now, 10 years now. The board itself has gone through many revision changes to keep it relevant. So even this ECU is drastically different to this ECU from 10 years ago. Now there's a lot of background stuff that has to be done to make that work, but we try to keep these as on the edge as we can, as new processors, new hardware. There's components that have gone out that are no longer in production. You can't get them anymore from manufacturers, so we've had to change those, update them. But this is still the trusty old Elite 2500 that it's always been, but just keep putting new parts in it to keep it relevant.
So like when you update your phone,
Yep.
right, it like runs terrible afterwards, right? Every time my phone updates, I'm like, this thing work? Is that
That's kind of what
problem there?
It's the opposite.
Like,
Yeah, it's not an Apple. It's not what we come up with a new one.
Hey,
It's-
now.
We don't slow down your old stuff when the new stuff comes
It's
out.
actually the opposite of that, because we try as much as we can to take whatever new technology we designed for these and move it into this. So the main reason that these got the update to the software was because we only have X amount of engineers, right? It's hard to find people that want to do this stuff because you can make a lot more money doing it for a bigger company than you can doing it for something that you like to do. So if we were able to make these run on the same software, firmware, all that fun stuff, then we only have to update one thing. So instead of having a team of engineers like you guys and you guys, well, you guys work on Elites, you guys work on Nexus stuff. Now we have one team that works on all the components together. And so that makes any update that we do to this, if they can make it fit in here, they will. So not all the updates that this get can come into here because this doesn't have the same memory, processing power, etc. But anything that we can fit from here into here, we do. Like when these came out, these had an oscilloscope built in. Well, back in 2010, nobody had oscilloscopes in their ECUs. That wasn't a thing that existed. Those came out around 2014, 15 was when it became a popular thing. Well, this got an oscilloscope added. So that was something we could do doing that update. We were able to free up some memory on how we process things in here and give it that ability. So anything that we can basically steal from a Nexus and put inside an Elite, we will. But they are reaching the end of where the memory is inside of them. So now it's kind of like picking, choosing what's the most valuable thing. They don't get everything, but they'll get the big valuable things that we can add to them. So
we're still making the Elites, but they are coming close to their end of life from a production standpoint. We've kept them as relevant as we can, but the architecture is just too old. So at some point, manufacturers are going to say, okay, you can't get that one very, very important part to make that ECU anymore, and we're going to have to just say, okay, full on board with the Nexus series from now on, because we literally have done everything we can to keep these in production, and we can't anymore.
yeah.
So,
But the nice thing, if you bought an Elite today, because that's all your budget would allow you, you're going to be on that same software. You're not going to have to get
Nope.
learn a new language on the new software when you get a Nexus.
Nexus software is new and it'll be out for probably the next, usually softwares come and go about every 10 years. So if the Nexus stuff just came out 2 years ago or so, we still got plenty of life in that software that this is going to use.
Okay.
And basically, like Josh said, the only thing that's limiting us on these is eventually we just won't be able to buy the parts anymore.
Gotcha.
Like he said earlier, this board's been through like 9 revisions because a manufacturer, like through COVID, that screwed us hardcore.
Everybody.
Because you got companies that make this really niche little electrical component that we need, that we put in our ECUs, and like you can't get it. So then you have to find somebody who makes something similar, but then you have to redesign the board to make it fit because it's a different footprint or a different layout or whatever. And so like it's been a nightmare to try to keep them relative, because a lot of parts that are in these things 10 years ago were like a part that everybody used. But now people like FPGAs, like these don't really use FPGAs anymore. Well, back 10 years ago, that was a huge thing that every electrical component had. They're basically impossible to find now. To find one that's like relevant and does what you need it to do, and it's not crazy expensive because it's a specialty part, like, good luck.
So I know a lot of acronyms. Can you help me out?
FPGA,
Yeah.
basically it's a field programmable switch inside there.
it's a computer and a micro switch.
Yeah.
Gotcha.
So that board goes on there to control minuscule
Pathways.
pathways and changes
So-
and strategies, and then the ECU does the heavy lifting, and all that thing does the sound processing.
So, what is the price, entry level price between the two to kind of get in?
2,500. So this is actually cool. These things are $2,000. They're
Okay.
1986, I
I
think
guess
is
it's
the
a
exact
good
price.
segue into, like, let's jump from there to there to there.
Okay, so $2,000. This was the top of the line ECU for the longest time, and then we jumped out with the Nexus. We had people that just wanted more. So we used to sell what was called a rim box. It looked exactly like this, but with a different sticker. And you could pair this and a 2500 together, and basically you had 2 ECUs that worked together.
Okay.
So you ended up with double the inputs and outputs, double the processing, all that fun stuff. You could do
16
16 injector
Okay.
for pro mod stuff. And we had a lot of people that were like, we want that, but we want it in one box. And so then we came out with the R5,
Okay.
which is that guy. And that thing will do 18 injectors sequentially, 12 coils sequentially. It has close to 40 inputs. It has a built-in 20-channel PDM. It'll do dual widebands out of box directly, both NTK and LSU.
Okay.
It'll do dual drive-by-wire. It's built-in G-meter, built-in Wi-Fi. Basically, everything that you would want in a car is in that one box, minus EGTs. So
Okay.
we have some drag guys that run that ECU, no fuses, no relays. Like trans brake, powered directly from that. Nitro solenoids, powered directly from that. Like coils, injectors, fans, pumps, like not a relay in the whole car. That thing's all solid state built in.
So give some Aaron Gregory's car entirely ran off one of those. Devin Schultz's car entirely ran off one of those. Alex Seidlow's car, one of those. Mike Waller's car, one of those. So the entire chassis, headlights, taillights, everything.
We've even done them in street cars.
So for switches, like when it comes like this the switch panel.
Use a CAN keypad.
So how do you program that? Can you like, okay, well I want, if it's at a certain RPM, I don't want it to activate this.
Yes,
Or
100%. You can have it with software logic, where you can go in and program conditions like what you're talking about, and then you can do overrides on a keypad.
so if you hit the keypad, it's the keypad. But
Yep.
if you just just hit the ignition, it'll do it
Yep.
as well. Okay.
Yeah, you can have logic and then you can have overrides.
You have
So
conditional inputs. So you could say, hey, I want this button to do this, but if RPM is below this or if manifold pressure is
don't want
above
that
this, then yes, exactly.
Yep. So
Can it do the current modulation? Like on the new
PWM?
transmission?
Yes.
Yep, new transmission.
Absolutely.
So I wanted to just bring something up that, I mean, so you said there's not gonna be a relay in the car, and something we've been running into is like, for example, like the basic 30 amp fuel pump relay. After it sits for a long time, or I guess maybe a lot of people run into this where the connector melts, and then it just, it melts.
Yep.
Stop using Marlboro pumps. I'm sorry.
So we keep going up and up in like higher amperage relays,
Yep.
but like if it's all solid state, it totally gets rid of that. You don't have to worry about contact resistance. Like that's been like the bane of our thing is like.
and the cool thing is you log it all. So
Yeah.
all the way down to like I can power the ignition coils off of one of the high current outputs. And one thing that we do that no one else does, everyone else's PDM is CAN based right now. There's no other ECU that has a PDM built into it. Well, CAN natively is slow in the big scheme of things. So these ECUs will log at 1,000 hertz, which is 1 millisecond sample rates. So 1,000 milliseconds in 1 second. And we can log a point every single millisecond.
You can see,
including the PDM.
like I said, that's so fascinating. Like your manifold pressure, you can see when the valves close and open.
So manifold pressure is not a nice curve that you always see. It actually does this. It stair steps its way up
Yeah, well, that's-
because that's how engines work. And you can actually log it fast enough. There's a channel on those called unfiltered map. And then there's a regular channel just called map. If you look at the unfiltered one, you can zoom in enough and actually reference your 0 to 720 engine angle, and you can watch the manifold pressure go down a little bit and then jump up more, and then go down a little bit and jump up more. Because that's really what's happening. It's just
You
most
could actually-
ECUs aren't
you
fast
could use
enough
that to
see it.
determine if you have a valve that's not closing all the way. You can use it to determine if a coil's going bad, if your fuel pump is dying. So you can see all of that through your data logs.
Like I had this happen last year. We had a guy, he had a intermittent misfire under heavy load, and we were powering the coils off the R5, and you could zoom in enough to actually watch the coil charge and then fire, and then charge and fire, reference it against engine angle, and found out all the coils were drawing about 10 amps, except for one that was drawing 4. Only under load though. And we just referenced again engine angle and then firing order, 1, 2, 3, whatever, and said, okay, well that coil's going bad. It's not dead yet. Car runs just fine when it's sitting here, but down track it has misfire. And that's how we found it, without having to. I literally opened a laptop and I actually did it over Wi-Fi. We were pushing the guy back to his pits on the golf cart, and I was on the golf cart. I Wi-Fi'd into the car in front of us when we were pushing him back and was looking at the data log. Got back to the pits. I was like, hey, we need to change coil number 4, and that fixed the problem. Didn't have to just throw parts at it. Like I was able to do all of that without literally doing anything other than opening a laptop. And so that makes these things they're so good for diagnosing stuff. Like I have so many calls a day where people are like, hey, I have X, Y, and Z problem. And usually it's down to wiring for most people, but every pin on all of the Nexus ECUs is current monitored. So even the outputs, I can tell you the voltage that's on an output. Even though the ECU is not supplying the voltage there, like an injector output, I can tell you the voltage that's on that pin. So if you've wired something wrong and you've crossed something somewhere, I can just look through the ECU and say, well, there's voltage on these 5 pins. They're not supposed to have voltage. Find out what you did wrong, trace them, fix it, call me back. And I can tell them that based on what the ECU is telling me. That also gives us the ability, outputs can be used as inputs. No other ECU on the planet does that. So like an injector output, I can run that to a trans brake button because I can see the voltage on an injector output, which means I can feed voltage from a trans brake button. So then I can use that as a switch inside the ECU instead of using one of my regular inputs. So my regular inputs I can save for fuel pressure, oil pressure, temperature sensors, position sensors, and then like a clutch switch, a brake switch, trans brake button, bump creep button, nitrous override, scramble, whatever. I can actually use leftover outputs for that.
Oh, so you can repurpose your outputs.
Outputs can be inputs. We're the only ECU on the planet that does that right now. And we did that on a diagnostic side so we could help people figure out what problems they had. Then we realized oh wait, we could just also
can see
use
the
that
voltage. We can make a
to
switch.
do other things.
You don't have to pick and choose.
Yep. So you can move stuff around and mix and match it how you want. And then the R5, those guys when they came out they were $3,900, but they came out in 19. What's up?
I was just gonna say, do you see a delay in signal by using an output from an input?
No.
No?
Voltage is instant. It's the cool thing about it. So
I guess kind of piggybacking off the question you had about mounting the connector.
Yeah.
So say if you have something shorts out, because I see a lot happens with PDMs, government trucks that always have with their PDMs, and it melts the connector on the R5.
I've never seen it happen. There are, I think, 13 temperature sensors across that ECU, and there's also pin temperature sensors. And you can see all of this, like none of this is like locked behind closed doors. Like every channel that is able to show you is active. Anybody, you can go plug in anybody's car that has one and type in temperature in your logger or in your channels, and you can see all of that, and it watches all of that, and it'll shut it down. The thing is, what we've seen, I've never seen someone melt the connectors on those, but that monitors voltage, amperage, temperature, everything. And so as long as you're smart enough to program when you want it to turn itself off, you'll never have that problem, because as soon as, like, when you have a loose connection like that, the amperage goes up is what happens, because you created resistance.
Because the software will tell you, hey, this is at the limit, or if you go over it, it'll say you're over the limit of the pin.
So like a 25 amp is 25 amp. The hardware is rated to 50 amps. The actual pin on the ECU is a DTP, a Deutsch pin. And Deutsch says this pin's rated at 25 amps, but that's continuous. So like people will use them and it'll spike, like fans on inrush will spike like 40 amps. You don't hurt the pin because it's 40 amps for 3 seconds and then it goes back to 20 amps and runs continuous. But yeah, I've never seen anybody melt the pins yet, because like I said, you can program all of that stuff. So as long as you don't go into 25 amp and say you're allowed to go to 50 amps all the time, whatever, like then you could melt something, but that was because you told it that it could do that.
Now,
So-
my question was like, if it was like something like that were to happen, then could you get it like send it out to get people?
Yeah.
Yeah.
Yeah, we can repair them. So it would go to Australia, but super easy.
It may not have to in the future. We hired a new repair tech, so hopefully he'll be able to do those kind of repairs for us in-house in the U.S. So we won't have to wait on it to go all the way around the world and come back. So, go ahead.
How flexible or configurable is the crank trigger pattern in that?
So it has probably 100 preloaded ones, and then it has generic ones where you can pick the amount of teeth missing, whole 9 yards.
Okay, but does the software have like a built-in expectation? So where I'm coming from is like the old AMs
No,
were
it's
based
not like
on
that at all.
they were expecting 12 teeth, and if
No.
you had any more or less than that, you had to kind of do some
No,
fuzzy
you can. I
math.
can literally go in and click it's a generic pattern and type in it has 147 teeth with 12 missing, and it'll still run. It doesn't matter. Yeah, we don't have that issue. And you have an oscilloscope, so even if you don't know the trigger pattern, I can literally watch the oscilloscope and just count the teeth and then tell you what your trigger pattern is on an engine that you don't know what it is. Makes it easy.
Oscilloscope work for all the different pins?
Yeah,
Like
you can.
monitor and
Yep.
checker with
You can
oscilloscope.
use every single input or output on that can be put on the scope.
Oh, that's
Because
awesome.
we said we can see voltage on every pin. Oscilloscopes just measure voltage.
I walk around.
And you can log from the scope too, which makes it nice. So then like I can have people like, hey, open your oscilloscope, put these channels in it, crank it, send me that log, then I can see their scope and the full data log from they were cranking it. So I can see the scope and every other value in the ECU. To be able to tell them like, hey, this stuff's set up wrong, change these settings to this, try this, whatever.
And the 2500 can do that now.
2500s can do scopes. They don't scope outputs, they only scope inputs. Only the Nexus has the ability to voltage monitor every pin. These do not. But you can still do inputs on these. So like
because of the
trigger
firmware
inputs.
limitations we talked about, it's obviously slower than either of these. So you don't have that 1000 hertz frequency.
Yeah, these will do 5 millisecond sample rates. So technically that log's 5 times faster than this does. Which 5 milliseconds is fast, but 1 millisecond is much faster.
The R5 is what's the price on that?
So that's what I was getting at earlier. So when these first came out, these came out in 19 and they were $3,900. And then COVID, all that fun stuff happened and components got hard to get. They're now $4,400. But to date, you cannot buy all that does from any other manufacturer for a cheaper price. I don't care, you go buy Megasquirt stuff. You can't piece together what that does in one ECU with any other brand on the market. Again, 18 injectors, 12 coils, 40 inputs, 20 channel PDM, dual widebands, Wi-Fi, G-meter, 500 channel logger. You can try, it doesn't exist. I tried. When these came out, I told everybody internally they're too cheap. Like they should have been $5,000 when they came out, because the closest I could get back then, when they were $3,900 in 2019, the closest I could get to replacing that was I think ECU Master, and it was close to $5,200, and they still wouldn't do 18 injector, 12 coil. So I had to give that up, but I could get everything else. And to date, like I said, there's still not an ECU on the planet that can do all of that for a cheaper price. And it's not in one box with one software. So, and then a lot of people are like, we really like that, but we don't need half of it. And so that's
when we
where
came up with
this guy came from.
This is the newest ECU from the Nexus line. It's the R3. It's basically the next evolution of the 2500, but in another sense of looking at it, it's the baby brother to the R5. So however you want to look at that, this is basically a 2500 with a built-in wideband, a built-in PDM, does dual drive-by-wire, Wi-Fi, all the stuff that you expect from the R5, just in a smaller package and cheaper. And this thing retails for $2,400.
So it's $400 more than this.
Which is not far off buying that plus a wideband at this point. So
there's no reason to buy it.
There's no reason.
Basically, yeah, we have these on the shelf right now because everybody buys those, which I don't recommend anybody to buy one of these. If you need one tomorrow, you gotta buy an Elite. You want one within a month, you gotta buy an R3.
Gotcha. It's a display model, so it's a little beat up from being
right before they
chucked around at races.
Yeah.
And
Well, most people that bought these, they weren't like the people that had these plus a rim. Those are those customers. Because you gotta think this is $2,000. That was double.
Just
the
like on
money.
the Elite. The Elite had built-in manifold pressure.
Oh, okay.
That disappeared on the R5s because we had so many inputs. You're like, why would you need it on there? But we brought it back for this one because this, like I said, this is kind of the evolution of the 2500.
Can you use that as just a barrel one if you want to
Yeah,
use
absolutely.
it?
So if you're not using it as manifold pressure, you can use it
It's
as
a 4-bar, so
or any kind of
4-bar of anything
pressure.
you want to measure, put it on there. The cool thing about those two is they have, so that is a 3 connector, hence the R3, that has 2 34-pin connectors on it, and then the big DTP connector. This guy has 2 34s, 2 26s in the DTP. The 2 34s on that and that are identical. So if you started out with that guy and you had it in a street car and then you were like, I want to go race car, you can literally unplug your harness. It'll plug directly into one of those.
Nice.
Load your map out of that into this, and it'll run exactly the same. And then you just have 2 more plugs that you can wire to.
More PDM outputs, more IO.
Yep. More injector outputs and stuff like that. So if you wanted to start with that guy and then upgrade to that guy, it's literally just plug it in, same harness, load the map, and you're done.
Those 2 connectors there are different than
Yes.
those 2?
Yes. 34, 26.
Okay.
So like this has 34, 26.
Yeah.
That one has 2 34s. So that one actually has more inputs and outputs than a 2500 too.
What I was gonna ask is, we use the same pins though, so.
Yeah, AMP super sealed. You can repin very easily.
Perfect, okay.
Yeah, I've sold tons of those with the connectors. So then instead of trying to repin the connector you already have and pulling all the wires out, not knowing where they go, you can literally take your harness and go pin for pin. Go in like an ignition 1, pull it out of this connector, put it in the new plug in ignition 1 and do 1 wire at a time. And there's only 60 wires here. So if it took you 1 minute per wire, which it won't, it takes you less than an hour to repin this to one of those.
So you might be doing that. So.
Super easy. I've done a bunch of them. It takes about 20 minutes.
My Evo actually has a Evo 9 patch harness that we sell for the Elites, and I just took the plug-in pins for one of those and did exactly that. Shuffled it all over to that and plugged that in, and I've been running that since.
So you said you have those the R3s on the shelf, but what about, are those on the shelf or is there a lead time?
So I have 3 R3s here, and we're selling them for $22.80 for this event. They're $120 off retail. And then the R5s, we don't have any with us. They're actually on back order. So those have been on back order for a while. Every time we get a new batch, they're already sold. So if you want one, get in line.
Yeah.
Can relate.
Yeah.
Were you saying that you have a harness that terminates in that and you want to convert it to that? And you
Yeah,
gotta
that's
repin
what I
it?
was getting at. Just see, obviously it's not gonna plug right in, but if you can just repin them, you can
Repin
just
it.
the harness. made
Super
for
easy.
You just take one of the 26, whatever, and convert it to the 32.
Yeah, I just, so we sell a plug-in pins kit with R3, so you can buy the R3 plus plug-in pins, and it comes with all 3 of the plugs and the pins if you want to like make your own wiring harness. Throw the pins in your toolbox and literally just de-pin this, because they're the same connectors, and just terminate it into the plugs in the proper spots, because the pin out from here to here to that is different.
And if you've not played with the connectors for these, they're super easy.
So there's no tools, you literally push one button on it and pull the pin out.
You take your fingernail and pop the lock loose, and then just pull the pin out the back. So.
And that's the same common Deutsch connector.
Yes.
Yep.
Okay.
Yeah, we made it simple. A lot of people use like goofy connectors when it comes to PDMs, or they use like a AMP connector like this and pair the outputs together. So if like a 25 output, they actually have 2 pins that come out and then go to 1 wire. That's kind of goofy, not a big fan of that. And so we used DTP, which is arguably the easiest connector on the planet to work with, and it's also the highest current rating connector as far as motorsports connectors go that are not like $100 a connector. So.
When do you expect to deprecate the 2500?
Whenever we can't build them anymore. I mean, we
Keep
still
building
sell
them
the
until we
platinum.
can't get parts for them anymore. So
Like the platinum ECUs from like
we
2005.
don't have a date on it.
We
It's
still sell them.
all about manufacturers and when they stop making the components because they are getting old. Some of the important ones are. So
And do you still have like the 1500 and?
Yep.
and
They all use the same components as these.
if you look at the boards, they're almost identical. There's some parts missing for the 1500 that are in the 2500. So that's why they're a little bit cheaper. We did discontinue the 1000 and the 2000 and the 550 back during COVID just to kind of cut back on, like you said, when everything was hard to get. We just wanted to keep the ones that were the most popular and the most functional. So we kind of got rid of those redundant ECUs at the time. So simplified the line as well. So
Yeah, we also, like, when those things came out, we did a lot of other cool things. So if you've used the Elites before, like, you have to have the ECU powered up to do anything with them. So you have to have it hooked up to a harness, whole 9 yards. All the Nexus stuff powers up over USB-C. So if you have a laptop plugged into
That's
it,
awesome.
it powers
That's
itself over the
awesome,
laptop.
yeah.
So on a bench, I can plug into someone's laptop or plug into their ECU, load a tune, set up everything, and then unplug it, send it to them. And so when they plug it in for the first time, like, everything's already set up how it needs to be set up. Also for like these cars, I can plug into a car, pull logs, make changes without the car having to be on. So all these cars don't have alternators and stuff, so when they're 16 volt, you don't want to sit there with the car on for 30 minutes while you're looking at stuff. I can literally plug into it and just power the ECU off my laptop and pull logs, change things, whatever.
I'm gonna ask for an extension cord for my laptop because it'll die. But
The ECU is a 5-volt ECU. Because your USB
These
is
power over 12 volt from
But your ECU, but your USB is 5.
correct.
Yeah,
Yeah, it just wakes it up
amplifies it.
so that we can communicate
Oh,
with it.
okay.
So
Yeah.
it doesn't actually power anything. It just wakes
It's not
up.
running the drivers or anything,
No,
it's just
right.
running the brain.
The actual power light will tell you that. So it's either green or yellow. When it's yellow, it's powered up over USB-C. When it's green, it's fully powered up over your power lugs.
Gotcha.
So you can actually look at it and tell you. And they also have lights on the front that tell you kind of what's going on with them. So if you didn't have a laptop, you could peek in and it has all your high currents on there and all your basic status light stuff. It'll tell you if your data logger's on, it'll tell you if your Wi-Fi is active, it'll tell you if you have check engine light, and then your main lights, one of the outputs are on, they're green. If they've tripped an overcurrent, they'll turn yellow to let you know like, hey, this is tripped an overcurrent, but it's still on because you can program how many times it trips
Right.
and if it's allowed to reset itself X amount of
So you can
times.
program drivers if
Yep.
you want to reset or not.
Correct.
Yep. And then
It's
if
at a
it's
maximum
tripped,
number of retries.
if it's tripped too many times, then the light goes red and it tells you the output's off. So like if the driver looks over and sees a red light on there, if you didn't have a dash for whatever reason, you could know like, hey, something's wrong, I need to stop doing what I'm doing and go at least look at it. If it's yellow, you might want to be like, oh, I need to maybe lay off it a little bit and not push the car as hard as I have been until I can have somebody look at it and find out why we went over current on something. But it makes life so easy. I had a GLTC car earlier this year start to run out of fuel, and he tripped the fuel pump over current because the fuel pump wasn't fully submerged. It drew a couple more amps than normal, and we had it on a 2-second reset. So it waited 2 seconds, kicked it back on, and then he realized like, oh, like I should probably go put fuel in this thing. When that would have normally been okay, blew the fuel pump fuse, car's on the side of the track, yellow flag everybody, go get a tow truck. It would have been a 45-minute fiasco to realize he was out of fuel versus a 2-second, the ECU handled it for me and I'm back driving again.
Right.
So I've also used the Wi-Fi on those. So there's a little SMA antenna on there that they come with. There's like a $30 one we sell that's a windshield mount.
Huh.
And it gives you about 300 feet of range.
So someone could be
We can
damn.
stick
I've
it
had
into
somebody
your
go
car
through
a good
pit
way down the
lane
track.
on pit limiter and pull the log off their ECU and radioed the guy and told him what was wrong with the car.
Huh.
So without him having to stop, he came through the lane, I Wi-Fi'd in, downloaded the log, he went back out on track, took it easy, came back in, I had a new map with some changes in it, reloaded it over Wi-Fi, he didn't have to stop.
That's awesome.
I tuned a boat actually from the shore. I did a hydroplane. You can't ride on those, they're
No,
one-seater.
you can't.
I tuned it from the shore. Because those, they're a direct shaft, so as soon as they start, they move.
Yeah.
Like they can't stop. And they have to get on plane, which is 100 miles an hour for them to cruise because they run no coolant. They pick up coolant from the rudder, there's a little tube.
Yeah.
And it has to go 100 miles an hour before the pressure in that tube makes it to the motor to cool it down. So they literally have to start and get to 100 as fast as possible. And it was a methanol blown 16 injector, 8 below the blower, 8 above the blower. It's the hardest thing I've ever tuned because you can't start it on land.
No.
You have to start them in the water and they have instantaneous load. So it's like, it'd be like starting a car and then just 100% throttle instantly. And like, I just had to figure it out. It took me probably 3 or 4 weeks to make that thing run. And it was horrible because they like crane them into the water. So like it's a 40, like if they crane it into the water and it doesn't start, you just wasted 45 minutes because they crane it into the water, they float it like 50 feet offshore, because when they start, if it's shallower than 10 feet, it'll clear the water floor out. You can see the bottom of the lake because the way the prop is designed, they're wild.
That explains why I always see them going down the freeway on a trailer sideways.
Yeah, they're so big.
I'm like, how they get it? Great,
Yeah.
Makes sense.
But yeah, and I did it all via Wi-Fi because that's all I could do. I was like, just stay as close to the shore as you can, basically, and do just white trash NASCAR. Just give me some laps. And I was just, every time he'd come close, I'd make some changes, and he'd kind of go away, and you'd watch the signal break up a little bit, and then he'd come back close again and lock back on, and I'd make some more changes.
Well, it's kind of fun. You can walk around the pits, and if you pull up your phone and like turn on your like looking for a new Wi-Fi connection, you see like Red Demon, Brittany, NTRR. You can just see everybody's Wi-Fi addresses in there.
I do that at World Cup.
Really?
Yeah, you turn it on and see who all has R5s around because they all project. Well, you can go in there and turn off the
Hopefully
Wi-Fi,
you're,
but everybody uses it because once you've used it, it's the great. Like it sounds dumb, it changes your life on how you tune things. I sit in people's campers at like the pro mod races and drink their beer in their AC. And I'm just like, leave the car on outside and then shut the door, and I'm using it on my laptop. I don't have to like crawl or monkey through a car anymore. I don't have to like stand out in the sun where I can't see my screen and sweat. Like
We did it yesterday when we came back with my car. We just sat in the trailer, and I left the car on behind the booth, and we just sat there and played with it.
That's
and you can live tune via Wi-Fi too. So anything that you can do plugged in, like when you're making changes, is all live. Wi-Fi is the same thing. So as soon as I make a change wirelessly, it's live to the ECU. Tuning methanol cars on a dyno, I don't have to sit in the car anymore. I can go like get one of the guys like, hey, sit in the car. I'm gonna go sit at this table outside the shop so I don't smoke my eyes out, and I'm just gonna Wi-Fi to the car, and I'll give you a thumbs up when I want you to run it, and then I'll shut the car down from the ECU if I see something I don't like. Like I don't have to be in the car anymore.
That's awesome.
Hopefully your cybersecurity game is on point.
Yeah, there's password and all that fun stuff. Yeah, it actually won't let you set it up without a password, but realistically, what are like.
How open is the CAN if you want to try to figure out how to like drive a factory dash or something?
So I can send you the CAN protocol, but unless you're really good at CAN, so we still don't have what we call user programmable CAN, but for the people that I've worked with, most people don't know how to use it anyway. They want it, like they're like, I want to program a factory dash, and it's like, well, if you want to do that and you have the ability, you could already do it from an Arduino. Like I've used Arduinos as a CAN bridge. You find the OEM protocol, you program that into an Arduino, I can send you the Haltech protocol, and then you literally just make the Arduino say this equals this. And if you can already do that, you don't need it to be in the ECU. Most, like 99% of people don't know how to use OpenCAN. They want it because they think it sounds cool, and other people are like, oh, we have OpenCAN. But dude, no one knows how to use it. Like even Motec doesn't have OpenCAN until you buy M1 build.
Actually, I went and talked to Mtron.
Yep.
Yeah, I went and talked to Mtron and asked him, I was like, how many people actually use the OpenCAN? They're like, no one. I was like, does it generate any like support questions? They're like, no one even tries. They're like, we have it. Like some people that know how to use it, use it. The people that don't know how to use it, just don't even touch it. So
yeah, all of our protocols are open. You can go to Google and type in Haltech like PD16 CAN protocol for our new standalone PDM, and it's already on the internet. Like you can download the whole file and do whatever you want with it. But again, 99% of people don't know what to do with it. There's a very small amount of people that know what to do with it, and those people typically sell the ability to program that stuff. Like again, like a regular Motec doesn't have OpenCAN. You have to have an M1 build package from a tuner who knows how to do it, and then the tuner can go in and program the CAN. Like that's what John Reed Racing does. All he does is he builds little patch harnesses and then writes the CAN protocol for these newer cars. You know, they're like a Hurricane or something. Like that's all he does. But he also charges like $6,000 or $7,000. Not even the ECU, just the harness and the protocol. And so it's like there's not a lot of people that know how to do it, and the companies that do offer it, they don't offer support for it. Like I have friends that work at Link, I have friends that work at Mtron. If you call Mtron like, hey, I want help programming this factory dash, they're not gonna help you. Like that's not it's your job to figure it out or go pay somebody to do it. Link's the same way.
But on a simpler side, like I got an AM serial gauge and I just want to get information off it.
Yeah, you can still do it. If you have the AM protocol and you know how to convert it, you can still get it in there.
It's not like drop down box.
No, we do have a bunch of drop down stuff in there. There's probably 30 different cars that are pre-programmed. And then we have a couple different ABS units and stuff like that. And they are gonna open up, like they're gonna put another drop down in there that's called third party CAN at some point, where you'll be able to select that stuff. But at that point, you're still trying to make product X work with product Y, and half the time it's not gonna be happy. And so it's kind of like, yeah, like all of our stuff is easy. That's like the big thing. All of our CAN stuff, like you don't have to program anything. You just plug it in, the ECU recognize, even if you plug it in and don't turn it on, the ECU recognizes it's there and starts using it. Like if you plug in a dash, it literally pops up at the bottom and says like under your CAN stuff, it shows you have a Haltech dash. You plug in a wideband and you don't turn on a wideband, it says wideband connected at the bottom. And then all you have to do is assign the sensor to what cylinder or what bank or overall or whatever. Most other companies, when it comes to CAN stuff, they still make you go in and like set them up. Like we've made it as dummy proof as possible because like ECUs are already hard realistically, like make the easy stuff easy.
That's
and
kind
so
of one of our
that's our
MOs,
logic.
Is give you the flexibility to do what you want to do, but do it in a way that is easy to understand. We don't want to make things so complicated that you spend weeks doing something simple. And just go in there and be like, I want you to do X, Y, and Z, and like you can figure it out really simply. We try to keep the complex stuff out of it as much as we can.
There's also
Now-
tons of help files.
Oh, yeah.
Little question marks that pop up in the software if you don't know what something means. Like click the question mark beside it and it'll give you a little cliff notes on what that thing is to try to help you understand what you're dealing with.
Are you getting into yet or dealing with wide bands per cylinder?
Yeah,
Oh, yeah,
we've already been able to do that.
Oh, okay.
Yeah, this will do 2 internally, but when you think about our CAN wide bands, you can do 12 wide bands. I've done V8 cars where I do two, like 1 per each bank, and they do 1 per cylinder.
Sure.
So, and you can already do that. So you can do up to 12 wide bands in all of our ECUs technically.
So this comes with 2, but you take another module.
Yeah, you buy the CAN ones. Well, you can put 12 on these. Yeah, they're just, you buy a bunch of the CAN ones. You end up with like $4 grand in wide bands at that point, but you can do it.
Well, I was just curious.
Like the nitrous guys or the all motor guys, the ones that I work with, they'll do 1 per cylinder and then they'll do 1 per bank because even the old Elite will still do bank to bank O2 control, which some ECUs nowadays still don't do that. But like it can look at, cylinders 1, 3, 5, and 7 and make changes just on that bank if you wanted to, and still do it in closed loop fashion with long term.
Can the R3 and R5 do individual trims?
Yeah, we've always,
So you can
even the
have-
Platinum from 2005 could do individual trims on fuel and ignition. We've had that
Closed
for,
loop.
if you want to,
Closed
yeah.
loop with the O2. If you had O2 per cylinder, let's say.
Yeah.
Okay. And
You
then
can set it up.
what about on forced induction cars? Typically your O2 sensors after the turbo, but if you want it per cylinder, there's before the turbo. And I know some of the OEs are starting to.
So you
program
can
that.
do that. The problem that you're going to find is there's no one on the market right now that tells you the calibration per pressure. So
Gotcha.
even if you go to Bosch and you download the internal data sheet for like an LSU 4.9 or even from the new ADV, which they boast is a pre-turbo sensor,
Okay.
if you look at the temperature ratings and the pressure ratings, it's like 50 degrees Celsius higher than the regular one. And they don't give you any calibration on when it goes into pressure. They provide you no data on what the actual wideband rating is. So anybody who does pre-turbo widebands are just guessing.
But the ECM Lambda Pro doesn't do that.
It's guessing.
But it,
Again, the person who makes the sensor tells you the sensor is not made for this.
right.
So you have to figure it out.
Like on the Coyotes, that we do that. Sometimes we have to target like 0.61 when really we're shooting for like 0.7. Or
Yep.
whatever.
So you can go in there and you can do an overall under your target lambda, and you can base it on EMAP.
Right.
And so then you can change your target lambda based on EMAP. But again, it's a guess. And so like you can guess, but if you're wrong, there's no data basically to back up what you're guessing for. Because no manufacturer of a sensor, even Bosch who makes a pre-turbo sensor, they don't provide you when it goes into positive pressure, they don't tell you how it scales the reading that the sensor gives you. They just say, well, the sensor's rated for that, but when you actually look at the rating, it's not. It's rated at like the same PSI rating and then 50 degrees Celsius more than the regular sensor.
Do they have the data? They're just giving it? Or they
No,
have
it doesn't
the data?
exist. Like it's
They don't
this,
test them
So
now.
the
OEMs
Lambda Pro
don't do that.
Has the
Technically,
pressure input.
the
It's
way
just
you run
full
these
crap,
sensors
but they
in
don't
the
have
cars
data to
now.
go off of.
Technically, the way you run the sensors the way they are now, it's outside the range of the OEs anyway. So they really don't give you a good calibration for the temperatures that these cars see. So even today, like if you're doing a turbo car, putting a wideband after the turbo and doing EGTs is still the most cost-effective way to get usable data.
And you kill the sensors. Like I've done the pre-turbo
Any
sensors.
backfire and the sensors.
Yeah,
done.
anti-lag, sensor's done.
Yeah.
High EMAP, sensor's done. Like they don't live there. And when you're spending $150 a sensor for a name brand sensor, and
If
you're
cut the
killing them
sensor
every
apart and
event,
actually look
like
at the element in there, you'll see why they break. I mean, it's just a little
Yeah.
ceramic thing, and it's thin, like wafer thin. And any kind of back pressure explosion in the manifold, and that thing's just done.
So you mentioned individual EGTs is basically the way to go. Is there maps in there that'll do fuel compensation based on EGTs?
So I build them, I call them feed forward tables because they're not closed loop. You have your individual cylinder trims and base one axis on that temperatures, or that cylinder's EGT temperature. So that as it starts to get hot, we just feed in extra fuel. So it's not full closed loop because it doesn't have a PID. But it's called a feed forward, so it's looking at real world data and it's making decisions based on real world data. So it's as close to closed loop as you can get without a PID.
Gotcha. Okay.
But
So
yes,
it's not,
you can do that.
It's basically making a correction, but it's not checking to see, did that correction get me exactly where I want to be?
It does in the table though, because when you look
Oh, yeah,
at
because
it
then
on
it's
this
just a
axis,
different
if it's
spot.
Look at the
temperature
result.
and it goes up, it's going to feed it fuel, which is going to push it down. So if you actually play it back, you'll watch it go up and then literally push itself back down because it's feeding in extra fuel. As long as the fuel that you're feeding it is changing the temperature. Most people don't realize is fuel doesn't have as big of a change on EGT as ignition timing does.
Yeah.
So you can do individual ignition timing as well, where you can go in and actually adjust that. So if you have like a wideband per cylinder, I'll do the fuel correction based on wideband per cylinder. So if it starts to get out of range, push it back, and then I do the ignition correction based on EGT. So you have both of them correcting per cylinder based on two different variables. One's doing fuel, one's doing ignition.
Gotcha.
So, but that you have a bunch of money in sensors. Most
Yeah.
regular cars are not gonna. These are like pro mod level guys who have $60,000 engines, and they want to keep them alive. So they'll spend $10,000 on sensors because they want to keep their $60,000 engine okay. But most people don't go that far. But yeah, you 100% can.
Going back to the wideband question, are there any for widebands or EGT sensors? Are there any intermediate boxes that you need, or can you just?
So EGTs, you have a box for those because they're called thermocouple amplifiers. So EGTs spit out like millivolts, really, really fine readings, and they're not very accurate. So you need a box to basically soften that reading and then convert it to something that's actually usable. And so we use a thermocouple box. We sell a 2-channel, a 4-channel, and an 8-channel box, and then your K-type thermocouples plug right into that. The widebands are direct to that as far as 2. If you want more than 2, then we have the same CAN ones that you'd use on like the Elite. And you can pair up to 4 of the 2-channel CAN ones together. So I give you 8 widebands, and then you can buy the single wideband channel box too and pair that. So you have access to a bunch of widebands if you want them. But I've done a bunch of cars, and it's very rare to find somebody that wants to do that. Typically, it's only the high level people, like a lot of pro stock guys, where they're trying to get like every ounce of horsepower out of something. Those are the ones I typically see that have individual widebands, just because like literally, like he'll call me 2-3 times a year and he'll order like 20 wideband sensors, and it's a couple $1,000s. And he's like, I just keep them in the trailer in case something goes bad, because he has 10 of them on the car. Like, you can kill one in an event pretty easily, depending on how hard you're leaning on them, because the sensors are never designed. Like, we actually modify the NTK sensors that we use for methanol cars. We modify the sensor. We put a shield on the top of the sensor.
That was going to be my next question. Has there been any work with sensor manufacturers to make a sensor that can withstand these conditions?
You got to think we're a big company in the aftermarket ECU world. We're a small fish in the OEM electronics. Like, if Ford's not getting them to make custom sensors for them, like, they're definitely not doing it for us.
So it's a compromise no matter what.
Yeah, you use the best OE sensor you can find, and then we modify them in a way that we can, that doesn't affect how they operate as far as readings, to try to make them more reliable.
I'm surprised there wouldn't be more of a market for that.
It's
like
crazy
for
money.
Like, why is
Just the production cost of those.
Yeah, you're
sensors,
talking
the
millions of
equipment
dollars.
to make.
Yeah, millions of dollars for something you're gonna sell for $200 a piece.
Yeah.
Like, it's not worth the
Some of the
investment.
Sensors are made out
Good on that
of
investment.
precious metals, O2s and platinum, and all sorts of shit.
Yeah, but like the NTK ones, we did modify those, but all it is a simple shield, but it stops the methanol from getting inside the sensor, because we run those at like 3 AFR, and if you've seen them, they spit methanol out of the car constantly. Well, you'll kill the sensors really quickly with that thermal shock, and so we put a shield on them to try to protect them from that. But even then, you'll still replace the sensor every 1 or 2 events. That's just normal. Like, that's costs of running that kind of car.
I think maybe the use case for it would be to just check the cylinder to cylinder variance for like fuel injector or whatever, intake manifold distribution, stuff like that. It'd be a very temporary thing where you at least get like a reading to see if one cylinder is a little leaner, but then you take them back out and plug.
Yeah, people do that, but you still have the upfront
The
cost.
variance.
So like, I'm still gonna spend $2,000 on putting 8 widebands in this thing. Why not just leave them there? I spent the $2,000. Like, I can either take that $2,000 off and put it on the shelf and not touch it again, or I can just leave it in the car. But yes, you are correct. I do know some tuners that do that. But like if you kill a sensor, one of their sensors, they'll charge you like $400 a sensor because they'll buy lab grade ones. And then the car also has to be set up for individuals. So then like you have to have your headers modified or whatever you're dealing with. So at that point, like if you're building a car and you're setting up for individuals, just keep individuals on it all the time. Like you kind of accepted the cost of running individuals versus putting them on and then taking it off. Because like the point is like things on an engine will change. And so like, yeah, we tune it at this place, this, you know, DA, water grain, all that fun stuff. And we take it like here or to Texas or to Florida or to Maryland or wherever. And it's like, how do we know that those are still right? Like we put it on there when we tuned it, but like the atmosphere has changed vastly and that will change how things operate. And so it's like, if I'm gonna spend all that money, I'm just gonna leave them on the car. But I do know tuners who do that. They put them on and take them off.
Out of the muscle car carburetor guys, they'll put oxygen sensor bombs with their own standalone wideband with clamps while they're tuning the car, and then just take them off and put a plug on it, which is pretty cool. I think they're a little test bench on it.
Yeah.
But yeah, I mean, there's a big value in having individual EGTs. I mean, pretty much most of the engine failures we ever see could have been prevented because if you had individual EGTs, you just know that that injector's going, you know, was bad or you had an issue.
They're nice for diagnostic stuff too. Like you have a misfire, like I was talking about earlier, like you can see misfires on EGTs because one cylinder will drop out and spike and stuff like that.
Exactly. It's funny because, you know, before narrow bands and wide bands, you know, you kind of look back at how people tuned engines back in the days with their little Hal meter with the
pyrometers, man.
Yeah, but before that was EGTs, and then, you know, there was these little things, and then, you know, when wide bands became readily available, people would start, you know, and cheap, people forgot that EGTs were pretty cool for doing stuff.
Right.
And they just got so reliant upon that nobody would put EGTs on anything. And then you got what I call Forrest Gump tuning. When people give you a safe tune, Forrest Gump, rich and retarded, which is the freaking worst thing you could do to an engine is to be safe, I'm running it, you know, on the rich side and I'm not putting too much timing on it. Well, that's just making an afterburner, basically.
Right, exactly.
And it is just, you know, my exhaust manifolds keep cracking. Yeah, I'm not surprised.
It's got 1,700 degrees in there, man. What are you doing?
But, you know, you hear people, well, it's running on E85, that's why I'm only running 2 degrees of timing. I'm like, okay, you know.
Fun fact, E85,
wrong direction.
You can run so much timing on E85 that it'll lose power before it knocks. Put a car on dyno, just keep feeding it timing, it'll start making less power, but your knock sensor won't show anything. Because E85 physically won't knock. Like unless you get 80, 90 pounds of
You do
boost.
something very, very wrong.
Yeah, you can like it's if you want to learn how to tune, like put a car on ethanol and put it on the dyno because you literally can't blow them up. Like unless you just run it super lean, but you can feed it so much timing that it'll lose 100 horsepower. And you just like start taking the timing back out of it and you'll watch it gain horsepower again. Like you won't hurt them with detonation, which is cool. Just run them lean, blow them up. But past that, like they're idiot proof.
Your probes for your EGTs, are they universal to other brands too?
Yeah, so we don't make our thermocouples. We buy them from a company that makes thermocouples for a living.
Okay.
Because it's much easier to like, we make ECUs, we're an ECU company. All of our sensors, like we sell nice like Texas Instrument.
Right.
Like our TI sensors, everybody thinks it stands for titanium. It's Texas Instruments. They make like NASA grade sensors. That's why they're $200 and not $50. They're not made in China.
And calculators.
Yeah, they're
Makes a badass
like
calculator.
we buy the nicest sensors we can buy from people,
I've
basically.
I've seen some of the probes they use some avionics. And
Yeah, they
those-
make 1/8 inch and they make 1/4 inch. Ours are 1/4 inch. They make smaller ones, but the smaller ones are not good with high temperature. They'll melt.
Oh yeah.
They'll actually bend, and then you can't pull the probe out of the exhaust.
Right.
You have to cut it, and then it falls into your exhaust, and you're like, well, you can take that apart now. So we use a little bit bigger EGT, which is the standard size for most people. But there are some companies who do an 1/8 inch one, but those ones do not like heat.
Now with our controller and our software, you can assign EGT probes as other things besides just runners.
Like
so you can
coolant
make it a
temp,
coolant temp, an
air temp, pre and post intercooler,
Yeah.
whatever. So if you buy a 4-cylinder, buy an 8-channel box, like what I have on my car, I have the 4, and then I have pre and post intercooler. I used to have, when I was in auto, I had transmission temperature. Because thermocouples, they measure anything, they measure temperature.
Yeah.
So any temperature I want, a thermocouple can measure it. The cool thing is in the software you can do a lot of pre and post. So like there's radiator, pre and post flow,
Sure.
and then it'll actually math out like how efficient your radiator is or how efficient your intercooler is.
That's what I like with the Volkswagens, because they give you a radiator temp and then an engine temp, and you can see if your radiator is losing efficiency.
Yep.
Don't those thermocouples have like an ideal range though? Like
like 2,700 degrees, 0 to 2,700 degrees.
Right, but don't they work better in a
No.
smaller portion of that?
They work
Or is it
everywhere.
I've dipped
pretty
them,
much
I've dipped them
even
in water.
no
Yep.
And they read exactly fine. And you take that water, you throw it in the microwave for 2 minutes and dip it in there, and it's dead nuts.
So whether you're in the range of like 1,500 degrees Fahrenheit
Doesn't matter.
or 200 coolant temp,
They're fine.
They read everywhere.
They're good.
Even on an engine, you can, like, I've had engines where like misfiring and stuff, and you can see it running like 150 degrees. And
Like
then
you
fix
said,
misfire and
they're
it'll
scaled
jump
in
up to
millivolts,
1,200.
tiny voltage range. So we amplify that through the controller to back to the ECU. So the range is very broad.
Plus the
It's really fast.
Yeah, I do some air cooled stuff, and they make thermocouples that are an eyelet that you can just bolt to something. So like bolt it to a pan or bolt it to a cylinder head, and it'll measure like cylinder head temperature.
Yeah, it looks like a Solar's ring terminal.
Yeah, it's literally a ring
Yeah.
terminal with a wire
Yeah.
that comes off it,
Yeah.
and it's
Put those on like air cooled Porsches.
Yeah,
You would know. You have.
Yeah, I have an air cooled Porsche.
Since they're so thin, how hard wearing are they in like a runner? Like
Doesn't matter. Metal. It just measures the temperature of the
Something that
metal.
was a good segue. Automatic transmission control.
Oh yeah, well, we have automatic transmission control. We've had it for a little bit now.
We used to do it generically before that, but
Yeah,
we
I
actually
tuned-
have a proper function for it now.
So
So
it'll do up to 10 speeds. So all of the 4-speed DSMs, you can control those. Like not just drag racing. I do a lot of A340 Supra tuning, and you can make them drive like better than stock, which is pretty cool.
Kevin is using one in his truck.
Yeah, he has a 10R80, and we're
Didn't he have,
controlling
like,
it.
Didn't
10R80.
he build a box for
He
that?
did. Yeah, he built a box to try to help convert some signals and stuff. But other than that, he's controlling it all through the Nexus.
Yeah, he uses it's controlling all of the
And
solenoids.
the function is there, but he's manipulating some data into it. So
Will the Elite be able to do that, or only the Nexus?
The elites can do trans control too, but you'll run out of inputs
very
and
very quick.
outputs.
Yeah.
Is the 6R drop down yet?
No, 6Rs. So we do it's weird. We do the 6 HP, which, so if you go back, the Falcons in Australia, they have a 6 HP, right? Ford just copied the design. So they didn't want to pay, I guess, ZF to make that transmission, so that's where the 6R came from. If you look at them, they're basically identical, except for some components are just like 10% bigger, and that's where the 6R came from. You can technically do a 6R, but you would have to go in there and know how to set it up. I'm actually working on prototyping the new ISF transmission. It's called an AA80. It's an 8-speed, but it has a direct shift solenoid, so you can lock the converter. So it shifts like a sequential, where there's no slip in between gear changes. And I'm running one of those. It's on a turbo K series and an RX-8, and we run it all off of a R5. But we're in the moment of running it off of a PD16. So then if you wanted to add that to your car, you would literally buy a PD16, buy the little harness that I'm helping develop, and basically load the transmission tune up. And then you wouldn't have to worry about wiring anything to your ECU, like you just can from your ECU to your PD16 and then all that's done. It shifts in about 70 milliseconds, and it drives, they're coming a brand new Lexus, like they drive really nice. We've put about 800 horsepower through it so far, and it still lives, but we're still finishing all of that development. The guy's building a new motor for the car. He just bought a 4-piston motor to try to make more than 800 out of it, because we want to see basically how much horsepower the transmission will hold before it blows up.
I have another one if you need an extra one of those.
An AA80?
Yeah.
Yeah.
I have one of their 10 speeds too. Don't they have a 10 speed also?
They have a newer 10-speed. I haven't messed with those.
Okay.
The
so-
reason I did the AA80 is because it's like an A340. It has all regular solenoid control. It's not tank-based in any way, and they make it in rear-wheel drive, all-wheel drive, and 4-wheel drive. So every Lexus or Toyota V8 6-cylinder, any of their cars that are rear-wheel drive layout, not front-wheel drive based, they all use that same transmission. So like if you wanted to put one in an off-road rig, they make an all-wheel drive one, or they make a 4-wheel drive one that's selectable with a transfer case. Their cars, they have an all-wheel drive one that's constant 50-50 front to rear. So it's the same transmission. It's basically just like the A340s were. The A340s, they put them in everything from like the mid-90s to the early 2000s. It's just that transmission, but 8 speeds, and it has a direct shift solenoid, so we can lock the converter from 2nd to 8th. So it's worked really well so far.
We're probably running into somebody else's time now.
Yeah.
Okay.
Last time. So. Sorry.
Did we have any questions before we give the floor over to someone else? I know we've ran over a little bit, so
You guys getting into EVs at all? Just curious.
maybe.
Yes and no. They're really expensive. If you looked into how much it costs to do an EV swap, most people do not have that kind of money. It's about $60,000
Yeah.
before you buy the batteries, the controllers, and everything.
At least.
Yeah, and that's like even buying used parts from Tesla, you're still like 40 grand. So.
Yes.
I have one more question. I don't think they'll mind.
It's your turn
It's your
anyway,
turn.
so.
It's your time.
The R3, does that also control all the relays, or is that specific to the R5?
No, R3 has a 10 channel PDM.
Okay.
So it has 4 25 amp outputs, and then it has 6 8 amp half bridges that you could technically use for like drive-by-wire, E-gates, exhaust cutouts. But when you're not using them for those, they can be 8 amp outputs.
Okay. I just want to make sure I had that straight.
Mhm.
Cool. Yes.
Back on the thermocouples, do you see a large variance from the thermocouple type and the location of it in the exhaust runner?
Yes, it makes a huge difference. In our instructions, if it is an NA car, the thermocouple tip is supposed to be in the center of the exhaust pipe. If it is a turbo car, it needs to be right at the
6 mil
cusp
in.
of going into the exhaust pipe. And then location makes a huge difference, even if they need to be obviously even from the valve. But like if you put it in the bend, exhaust gas has mass, and so like in the bend of a corner, if you put it right there, it'll read much hotter than if you put it in the inside radius. So like you have to look at the manifold and kind of make some smart decisions on where it needs to go as even as possible and in the same location, even if it means some are pointing straight up and some are coming in from the side. You have to look at like how the bends come out, because most manifolds don't come out perfectly straight. They all come out and go a direction. You need to make sure that the bung is in the same ideal location for each runner.
There's another aspect of that too, is it may be the same on the manifold, but is it the same inside the head? I've seen heads that are built where a valve is closer or further away based on the
2J
channel of the head.
turbo
Yeah.
cylinder
So,
heads.
Yeah, you want
the
to
outside runners are
measure
different,
it from
so
the
you have to
valve.
plan for that accordingly too.
Yep.
Is it ideal to put it?
Yeah.
Is it ideal to put it as close as possible to the head?
Yeah, because we want to read hot, like how hot it is, right? We technically want to know cylinder temperature. We can't put it in the cylinder, so we want the closest thing possible, which is as close to the head flange as possible.
That's what I did many years ago. I had 4 probes, and I just put it in
As
possible
close
to the
as you
head.
can.
Yep.
And
Leave yourself
we
room
had
for
a
the-
gauge that had 4 needles in it. It was a West
Yep.
aviation gauge, way back in the day.
Yep.
And it had 4 needles on it. We had to watch each one. Like, okay, wait, that one. so it was neat. But we got it as close as possible. But I didn't follow your recommendation as far as going down. I just put it in there like, oh, that looks fine.
They have to be exact, because you think if more of it's exposed, it's going to hold more temperature.
I was very young.
Yep.
I just got it in the hole. I'm like, okay, it's in the hole. We're good. Tighten it up.
Yep. Now the depth makes a huge, like 400 or 500 degrees. If they're in the wrong depth, like it'll be that much different, because your surface area of your sensor is getting blasted with, like if you have this much getting blasted with exhaust gas versus this much, like one's going to be way hotter.
Yeah.
So it makes a huge difference.
We melted a few of them just because we used it because they're really small. They're really thin.
Yep.
And just disintegrated into nothing.
Yeah, I've seen people tune themselves into a hole because somebody put the temp sensors in the tuner. Like EGTs, you don't tune for EGTs until the car's done. Don't even pay attention to the data. Tune the car like you normally would, and then look at it to make your decisions. But he started trying to do that up front, and the depths were wrong. So he was like adding fuel to certain cylinders and changing timing, and like ended up hurting the motor based on somebody installing the EGTs improperly, because he was reading that data and never questioned, like, is that data real? A lot of people just look at a number and say, oh, that's the number. And it's like, if it doesn't make sense, it's not the right number. Like, data can lie to you. You have to look into it a little farther sometimes. But yeah, the placement is huge on those.
As far as a Y-band, can you put them, we've always put Y-bands in the factory oxygen sensor location, like on a street car. I pull the original oxygen sensor
that's
out,
fine.
and then, because it had the output for the EC, it's not easy to see the,
Yeah.
then just throw a code,
Yeah.
and then still put it in the same location as the stock. I didn't know if that was okay, or if it was
That's
somewhere
fine.
else.
Yeah.
No.
Or if it way downstream, or.
Nope.
Figure out where to put
Rule
it.
of thumb, or at least my rule of thumb, there should be no openings in between where the O2 sensor is and the closest, like, so if like you have a header, the only gap I want is the head to the manifold. I don't want another break in that exhaust pipe before my O2 sensor, ever. Because that's just one more chance for it to let air in if the seal goes bad and then skew your reading and you have closed loop.
The
Hurt
Y-band
something.
as close as possible to a turbo, if you're turbo.
Yeah, a lot of people think putting them really close is actually bad for them. No, they have heating elements inside of them, and we use the ECU or the controller to keep the sensor hot. And so if the engine will keep it hot, that's less work that the controller has to do, because the sensors have a range they work in. That's why the sensor heats up when you first power the car on. It's not an accurate reading. Like an old AEM will show 8.5 to 1 for the first 30 seconds because the sensor's not hot yet. So if you can help the engine keep the sensor hot, that's actually better than letting the controller do it. It'll make the sensor last longer too, because you're not purposely heating the element inside of it, using an exhaust gas to do it, which keeps that coil inside of there from burning out over X amount of time.
Thank you all. Appreciate it.
Thank you, guys.
If y'all have any other questions or think of anything, please stop by the booth, visit. We have t-shirts and sensors. One last thing, I'm going to embarrass my cousin. He brought his entire wedding party because he's getting married in a couple weeks.
All right.
It's also his birthday today. So happy birthday, Noah.
Bachelor party.